Good morning, everybody. So today we solve some problems on Euler's theorem. So here the problem is verify Euler's theorem for the function u is equal to x raised to half plus y raised to half into x raised to n plus y raised to n. Okay. So this is the problem. We have to verify Euler's theorem. Okay, so first what we do, we find the degree of the homogeneous function. Okay, so first we check whether this function is homogeneous or not. If it is homogeneous, then we find its degree, correct? So to check homogeneous, so what we do here, u is equal to solution, u is equal to, okay, so here I take highest degree term of x, okay, so that is x raised to 1 by 2. So I will take x raised to 1 by 2 as common. So here you will get 1 plus here y raised to 1 by 2 divided by x raised to 1 by 2. And here also I take highest degree term x common. So here highest degree term is what? X raised to n. So I take x raised to n common. So which is 1 plus y raised to n by x raised to n. Correct? Or this is equal to, now this x raised to 1 by 2, this is x raised to n. So bases are same. So indices must be added. So 1 by 2 plus n, it is 1 by 2 plus n. Now into 1 plus y raised to 1 by 2 divided by x raised to 1 by 2 into 1 plus y raised to n divided by x raised to n. Okay. So now it is of the form x raised to n into f of y by x. Okay. So the given function, this function can be written in this form, x raised to n. This is our function of y by x. Okay. So which means this is the degree of the homogeneous function. Okay. So therefore u is a homogeneous function of degree n plus 1 by 2. Degree n plus 1 by 2. Okay. So here, so this is the degree of this homogeneous function. So u is a homogeneous function of degree n plus 1 by 2. Okay. So now that is n is equal to n plus 1 by 2 we write. That is, n is the degree of homogeneous function. So n is equal to n plus 1 by 2. Okay. So now in this case, now by Euler's theorem, so what we have, x dou u by dou x plus y dou u by dou y is equal to n into u. Correct? Is equal to n into u. Okay. So now we know what is u. So u is equal to x raised to 1 by 2 plus y raised to 1 by 2 into x raised to n plus y raised to n. Okay, so now we determine dou u by dou x. So differentiating with respect to x partially, dou u by dou x is equal to, so while differentiating with respect to x, keeping y as constant. Okay, so now observe that here in both the terms x is present, so we need to apply product rule. So first function as it is differentiate the second function. So differentiation of x raised to n is n into x raised to n minus 1 plus, now we are differentiating with respect to x, so y is constant, so its differentiation is 0. Then plus second function as it is x raised to n, y raised to n as it is. Now differentiation of first function, again differentiating with respect to x means here y is constant, so it is 1 by 2 x raised to 1 by 2 minus 1, right? So which is equal to I simplify this, n into x raised to n minus 1 into bracket x raised to 1 by 2 plus y raised to 1 by 2, then plus 1 by 2 x raised to 1 by 2 minus 1 is minus 1 by 2, okay, into bracket x raised to n plus y raised to n, x raised to n plus y raised to n, or in other words then multiply with x, okay, multiply by x both sides. Okay, so here x is there, so multiplying with both the sides with x, we get x into dou u by dou x is equal to, so here when I multiply with this x, then we get 1 by 2 into x raised to minus 1 by 2 into x into bracket x raised to n plus y raised to n, x raised to n plus y raised to n, so which is equal to 1 by 2 as it is, x raised to, here 1 means 1 minus 1 by 2, it is plus 1 by 2, x raised to n plus y raised to n. So this is x dou u by dou x. Next we differentiate dou u by dou y partially with respect to y. Okay, so this is u, right? So this is u. Now we differentiate this u partially with respect to y, so keeping now x constant. So first function as it is, differentiation of second function. So in the differentiation of second function, so here we are differentiating with respect to y, so x is constant, so this term is 0, differentiation of first term is 0, so it is 0 plus y raised to n differentiation n into y raised to n minus 1, then plus second function as it is x raised to n plus y raised to n. Next differentiation of this one, so this is 0 plus 1 by 2 into y raised to 1 by 2 minus 1. Okay, so now simplifying this, we get dou u by dou y is equal to so n into y raised to n minus 1, n into y raised to n minus 1 into x raised to 1 by 2 plus y raised to 1 by 2, then plus 1 by 2 y raised to 1 by 2 minus 1, it is minus 1 by 2, right? So it is minus 1 by 2 into x raised to n plus y raised to x raised to n plus y raised to n. Okay, so now multiplying with y, multiply with y both sides, so we get y dou u by dou y is equal to, so here n into y raised to n minus 1, I multiply with y and I write the remaining terms as it is, x raised to plus y raised to 1 by 2, then plus 1 by 2 into y raised to minus 1 by 2, again I will multiply with y into bracket x raised to n plus y raised to n as it is, so which is equal to n into y raised to, here minus 1 y raised to plus 1 get cancelled, so it is y raised to n into x square plus x raised to 1 by 2 plus y raised to 1 by 2, then plus 1 by 2 into y raised to, here y raised to 1, 1 minus 1 by 2, it is 1 by 2, 1 by 2 into bracket x raised to n plus y raised to n. Okay, so this is y dou u by dou y. So now call this equation as 1 and this as 2. Okay, so now adding 192, add equation 1 and 2. So we get x dou u by dou x plus y dou u by dou y is equal to, okay, so x dou u by dou x is, this is x dou u by dou x, which is equal to 1 by 2 into x raised to, okay, so this is 1 by 2 into x raised to 1 by 2 into bracket x raised to n plus y raised to n. Okay, this is x dou u by dou x plus, next y dou u by dou y, so this is y dou u by dou y. So y dou u by dou y is n into y raised to n into y raised to n into bracket x raised to 1 by 2 plus y raised to 1 by 2, then plus 1 by 2 into y raised to 1 by 2 into x raised to n plus y raised to n. Okay, so now in this we simplify this equation. Now in this case we can take 1 by 2 is common from the first and the third term. I take 1 by 2 common, and x raised to n plus y raised to n, it is also common, right? So taking those terms as common, 1 by 2 into x raised to n plus y raised to n, and in bracket I left with x raised to 1 by 2 plus y raised to 1 by 2. Okay, y raised to 1 by 2, then plus n into y raised to n, x raised to 1 by 2 plus y raised to 1 by 2, x raised to n by 2 plus y raised to n by 2. Okay, so now again in these two terms, x raised to 1 by 2 plus y raised to 1 by 2 is common. Okay, x raised to 1 by 2 plus y raised to 1 by 2 is common. Okay, so taking that common, we get so here one more term, I think we forgot one more term here. Y dou u by dou y is equal to, okay, so n into y raised to n, y dou u by dou y is equal to n into y raised to n, right? N into y raised to n into x raised to 1 by 2 plus y raised to 1 by 2 plus 1 by 2 into x raised to n plus y raised to n, correct now. Okay, so now this is correct. Next, x dou u by dou x, is x dou u by dou x. Okay. Oh yes, this we have this term, so we forgot to write, right? So this is of multiplying, we get with this multiplying n into x raised to n into x plus y raised to 1, then plus, okay, then plus this also we have to multiply with x, okay, because this dou u by dou x contains, there are two terms in dou u by dou x, okay, there are two terms in dou u by dou x, but we have considered only one term, right? So one more term I'll write here, plus here I multiply this with x, so which gives x raised to minus 1 by 2 into x, correct, into 1 by 2. Okay, wait a minute, I will write once again. Okay, so x dou u by dou x, multiply this with x. Okay, here the first term is also multiplied with x. So this is n into x raised to n minus 1 into x into bracket x raised to 1 by 2 plus y raised to 1 by 2, 1 by 2 plus y raised to 1 by 2. Next, the second term is plus. This is also multiplied with x. So plus 1 by 2 into x raised to minus 1 by 2 into x into bracket x raised to n plus y raised to n. And after simplifying this, you will get x raised to n into x raised to 1 by 2 plus y raised to 1 by 2, then plus 1 by 2 into x raised to, here x raised to 1 and x raised to minus half, so 1 minus half is half, so 1 by 2 into x raised to n plus y raised to n. So this is x dou u by dou x. Now this is equation 1. Now adding equation 1 and 2. Okay, so adding equation 1 and 2. So here we will get x dou u by dou x is equal to x dou u by dou x. Here n into x raised to n. So this is actually we should take n into x raised to n. So n into x raised to n. Okay. N into x raised to n into x raised to 1 by 2 plus y raised to 1 by 2, x raised to 1 by 2 plus y raised to 1 by 2. Okay, then plus 1 by 2 into x raised to 1 by 2. Okay, plus 1 by 2 into x raised to 1 by 2 into x raised to n plus y raised to n, correct. So this 1 by 2 x 1 by 2 into x raised to 1 by 2 into x raised to n plus y raised to n. Okay, then plus y dou u by dou y. This is y dou u by dou y. Now in these two terms, from the second and the last term, I take 1 by 2 x raised to n plus y raised to n as common, and I will get this term. Okay, this term will get, so this is, then plus from these two terms I take n into x raised to 1 by 2 plus y raised to 1 by 2 common, and I will get one more term here into bracket x raised to n plus y raised to n. Again in these two terms x raised to n plus y raised to n and x raised to 1 by 2 plus y raised to 1 by 2 is common. Okay, 1 by 2 is common. So we get okay, so in these two terms, okay, this y raised to n will not come because we have taken x raised to 1 by 2 plus y raised to 1 by 2 as common, n into, then in bracket x raised to n plus y raised to n is left. Okay, so now from these two terms I take x raised to n plus y raised to n into bracket x raised to 1 by 2 plus y raised to 1 by 2 as common, and I will get in bracket this is n plus 1 by 2, n plus 1 by 2. Okay, so now this is same as n plus 1 by 2 into, this is nothing but our u. Okay, so this whole is equal to what? equal to u, correct? So this is u. So therefore x into dou u by dou x plus y into dou u by dou y is equal to n plus 1 by 2 into u. That is, n plus 1 by 2 is what? Degree of the homogeneous equation. So n plus 1 by 2 into u. Okay. Hence it is verified. Hence it is verified. Okay. So with this I conclude this class and continue in the next class. Thank you.